So the way that I'm going to do your quizzes is I'm going to basically, for each section, I'll take 5 questions, and I'll have to make multiple versions that are just like the ones here. So if you understood if we go over these, after we go over them and you understand us going over them, then you should be able to do those ones like that on the quiz. Now they'll probably have different numbers with them, okay, but they'll be worded almost the same, and so that way that's your incentive to pay attention and go over these with us. All right, number 1, that was just put in one variable stats, and so that was a straightforward mean, median, mode. It's all good on that. This one, I talked to you yesterday about having to do one variable stats of list 1 with list 2's frequency, and you get a standard deviation of 1.5. Now, I got people yesterday asking me, how do I know if I'm using S of X for the standard deviation or the sigma of X? And the answer is the S of X is based on a sample, and that's what this is. This is your sample standard deviation. Sigma of X is the standard deviation of the population, okay, which is not what this is. So that's how you know you're using S of X. Okay, this one, the book says 1 only, and I disagree, and I say it's 2, and I could maybe even argue that 3 is correct, but in hindsight I think I would say 3 is a no-go. But I think 1 and 2 are right. So let's talk about that, why I think that. First of all, in a normal curve, do you have pieces of data that are out here far away? Yes, you do have data that is far away. It's just very low probability of getting those. So that's why statement 1 is true. It says they are natural variation, but rare. That's what happens. That kind of thing is what causes a type 1 or a type 2 error. Yes. Yes. Okay. Number 2 says they indicate that something may be wrong with the data collection process. I experienced this last week. That's why I say, heck yeah, I know 2 is true. Because last week, when we did simulations, some of y'all let 0 and 1 be Tiger Woods. I had let 1 and 2 be Tiger Woods. And I was asking everybody what kind of numbers averages they were getting. They were getting averages from 5.5 to 6.5, and I had gotten 9.5. Well, first period I was like, that's weird. I thought maybe the other person was wrong. Okay, silly me. Then throughout the course of the day, everybody was getting from 5.5 to 6.5, and I thought, whoa, I got 9.5. I think maybe I'm the one who needs to recalculate and look at my data, and I did, and I was wrong, and my true average was supposed to be 6. So I had an error in my data collection process that made it be an outlier. All right, 3 I think is right because it says they aren't important. I think it's important to look at outliers. It says they should be identified and then ignored. Do you know that when I determine your curves, sometimes I will take, if there is a way, way low outlier, like somebody got a 15 on the test, and that's way low than all the other data, I will knock that one off before I figure out what the curve should be. Because that one person is going to really mess up, significantly impact the curve, and that one person is not representative of the rest of the data set. Okay, so sometimes you do that, and you look at it, and then you want to knock it off since it's not representative. Okay, this one here we talked about yesterday, how those areas need to total up to 1. So on number 1, shape 1 and shape 3, you physically had to calculate the area of that triangle, and over here on shape 3, I did a rectangle and a triangle. And they do total up to an area of 1. Shape 2 has a negative area down here, and you can't have a negative probability. So 2 is a no-go. And so that's why 1 and 3 are the answers there. Okay, number 5 actually uses that idea statement. Which one is the true statements about a probability density curve? Statement 1 says the area is exactly 1, and that is true. Area under every curve, probability curve, is 1, because that's 100% of the data. And 3 is also true. It has to always be positive. You cannot have negative values because you can't have negative probabilities. But 2 is wrong. 2 says it does not model the distribution of the data. Well, that means that this curve is not showing the way that the data is distributed. Well, yeah, it is. That's how the function is made. It is showing how the data is distributed and where it's more frequent and where it is less frequent and so on. All right, moving on. Number 6. Okay, now I showed you guys our little thing for transformations. This, I hope you did not go through and add 50 to every piece of data and recalculate. This was showing that they did a transformation by taking all the data. So here's our little picture of all of our data, and they add 50 so to every piece. So therefore you can tell the center changes and adds 50, but does the spread change? Okay, so let's see. Center increases. Now, our song about transformations, a transformation means every single piece of data has 50 added to it. You can't just add 50 to some of them and not to the others. That's a whole nother, that's not considered a transformation. 7 is another one. The 5-number summary is the min, Q1, median, Q3, and max. What do you use the 5-number summary for? Good, to make a box plot. Excellent. Okay, so here I just put it in L1 and got one variable stats. You can go down on your calculator in the menu and it shows you that 5-number summary at the bottom of the menu. Okay. And this one was another one. By the way, on this problem, if you chose D, then that tells me you are not doing the calculations in your calculator correctly. If you chose D, then you're just doing one variable stats of list 1 alone. If you chose D, all that you're averaging is 0, 1, 2, 3, 4, 5, and 6, and then you're averaging that. Okay? But you have to do list 1 with list 2's frequency because there are 12 zeros and there are 8 ones and there are 17 twos and so on that you have to average. Yes, ma'am. Okay. I don't know. I'd have to look at it and see why that did that. Okay. Good. Moving on. We're good? Okay. Here. Now, this one, the moral to the story of this problem is that sometimes you have to get very technical and you have to get into the nitty-gritty of calculating stuff for the numbers. For example, I went ahead and I did one variable stats for each data set. Okay, and I determined a couple things because it talked about using the measure of center as mean or median. Now yesterday, based on our songs, what is going to indicate which measure of center I should use? How will I know? If you have skew, then you must choose to use, median and IQR. Okay, so what is the factor that's telling me that's going to determine whether I need to use median or mean? The shape, and that's if you have skew or outliers. All right. So knowing that, I went and I was first curious. I was like, hey, if I compare the mean and the median, then I can tell the shape. And I compared the mean and the median. It was skewed left. And the mean and the median on this one told me it was skewed right. So I thought, hey, they're both skewed. So maybe I should use the median on both of them. And answer choice D says to use the median on both of them. And it tells me that the median is 6.2, but it's not. So I was like, oh, well, dang, I guess that means that I'm not supposed to use the median on both of them. And it also says 10 is an outlier and 15 is an outlier. So at that point, I'm already thinking in my mind, whoa, I'm going to have to technically compute if those are outliers or not. And so I did that. I went up here and I used the fence rules, the 1.5 times the IQR. And I got the fence. Up here the fence was above 10, so 10 isn't an outlier. But on this one, the fence was at 10, So 15 is an upper outlier. So 10 was not an outlier. 15 is an outlier. At that point, I knew what I could do. This says they both use the mean and that there are no outliers. This one says the first set you can do mean because there are no outliers. That is true, no outliers in the first set, but data set 2 uses the median because 15 is an outlier, and so that was true. And so then the other ones had problems. This one says data set, oh wait, that's true. Oh, it switched it up. It says data set 2 you should use the mean. Anyway, so the other ones had problems. This one says also use the mean for both of them, and that's bad. Okay, so the moral to that story, sometimes you got to get down to the nitty-gritty numbers and find your outlier, fences, and all that. Okay, the moral to this one is to know what a percentile means. A percentile means the area below. If you are in the 90th percentile of your height for your age, what does that mean? You're in the 90th percentile for your height of your age. Then you are taller than 90%. So 90% of people are below you. So percentile is the area below. And then it says, how many standard deviations is that? Well, a z-score is your number of standard deviations. So therefore, I knew, I need to get a z-score for the 90th with 90% below. And that inverse norm of the area below is the z at that spot, so I inverse normed 0.9. Okay? Here, I like this one. This one says we get the shortest player. So we get the shortest player and you subtract 12. We get the median player, which I don't know where, he's somewhere in here, and you add 12. And the question is, how is that going to change the mean and how is that going to change the standard deviation? Well, guess what? If you subtract 12 and add 12, that's been a cumulative change of nothing for the sum. So the sum is still the same of all of those numbers, therefore the average is still the same. I guess technically, if you wanted to get down to it, you could go and recalculate all of those things since they gave you all the pieces of data. But I could totally see them giving you this kind of thing without giving you these numbers here and ask you to know how to do that. So if you're subtracting 12 and adding 12, the mean will stay the same. But if the smallest is now farther away and the middle one is now way up here, what does that tell me about my spread? It's more varied. So if it's more varied, then I have increased my standard deviation. Okay? All right. Next, number 12. Okay, hope you can get that one. I'm not going to do that. That's just one standard deviation up, so mean plus one standard deviation. Okay. Here again, percentile, area below. They want to know that with a mean of 72 and a standard deviation of 4.2, what is the percentile of this location of the x value? So I did x minus the mean over the standard deviation, and here's the z at that spot, and that's negative 1.67, and then I want to find the percentile there. And percentile is that area below. So how can I find this area below? I'm going to norm CDF from negative 99 to negative 1.67. And it gives me 0.0475, which it asks me to round to the nearest whole percent. And this would round to 5th percentile, 5%. Okay. I feel like I'm going through these at like lightning speed. Am I going too fast for you, for y'all? I'm going too slow? I don't know. Yeah? Okay. Just right? Okay. Here we go. It's Goldilocks. Just right. Okay. Here, this one was another straightforward normal model problem. Find the area between 100 and 115. So I had a z-score for the $100 amount, a z-score for the 115 amount. I got norm CDF between two z-scores, and that was 94.1%. So your x minus the mean over the standard deviation. X minus the mean over the standard deviation. All right. Next. Okay, I hope you could do that one. Think that should be a quiz problem? Yeah? Okay. Ooh, how about our centers? Now, we had some debate on this in my second period. We really don't, even though mode is technically considered a center in statistics when we talk about measures of center, we just really don't use it mathematically to represent the data in statistics, because your mode could be something way down, in a totally different place than the rest of things. So mode is just not a good representation of the data. We want to use mean or median. So among the mean and the median, which measure of center is resistant to extremes? What does it mean to be resistant? It's what? Not affected by. Good. All I know is that I need resistance. Okay? The measure of center that is resistant to the skew. Okay? But then at the end of that song it goes interquartile range and median. Why is it not interquartile range for this answer here? Yeah, it wanted center, not spread. IQR is the measure of spread that is resistant to skew. Okay, here was another one where you had to technically compute the fences. You had to do Q3 plus 1.5 IQRs, which is an upper fence of 19.5. That's right here. And so therefore, the max of T is above that fence. So you have an upper outlier. Okay? The lower outlier was at negative 4.5, but the minimum was positive 3. So you do not have a lower outlier. By the way, you'll see extreme outliers referenced here. I don't know if you remember, it was just a quick little blip I told you way back when we did this chapter. But extreme is not 1.5 IQRs, but 3 IQRs outside of the box. Okay? So 3 IQRs. There were nothing, it was not extreme. Okay, moving on. This is a horrible problem. I mean, there's so many things wrong with this graph. I don't even know where to. I don't want to even have a discussion on it because there's just lots of debates that we could go over as to what the heck. I mean, first of all, why do they even have 0 on here? It's talking about the number of cat owners, and it gives this thing of 0 cat owners. I mean, why? I mean, that's not a cat owner. They own 0 cats. So I'm confused. Okay. So here, let's move on. Which of these statements is true about standard deviation? And it is sensitive to spread. I mean, it is the spread. And so it is not resistant. It is affected by extreme values. Okay, although I'm wondering, why is 1 not a thing? Because if the mean changes and nothing else, I mean, I guess, I don't know. The other thing, I don't know. Okay, moving on. Oh, how about the, okay, I have this problem in here to always remind me. Sometimes I put these problems that have issues because they remind me to have a discussion with you. And in this case, this prep book would have gotten marked off on the AP exam. This technically, you do not call something like that on the AP exam. Do not tell me that that shape is normal. You don't know that it's technically a standardized normal curve. Okay? So they would mark off for you if you described the shape alone as normal in that instance there by just looking at that histogram. The better way to describe its shape is unimodal and somewhat symmetric, or approximately symmetric. Right, nearly normal. See, because I know then that's how we conclude our conditions and that kind of thing. I don't know. I don't know. I just know that in the AP grading guidelines, they knocked off on people who described a shape as normal, on just like looking at a picture shape. Okay, now these ones, mean, median, and then don't forget our rest of this is mode. And so if you know this thing right here, then you can so totally figure out the rest of those. Okay, good. It's skewed to the left, so the mean is less than the median, and that's less than the mode. Okay, this one is skewed to the right. So mean, median, and mode. So the mean is greater than the median, and that's greater than the mode. So 1 and 3 are the answers. And then this last one here. Okay, so when you subtract the mean and divide by the standard deviation, guess what that is describing? X minus the mean over the standard deviation. So they are standardizing all the data points. If they standardize them all, they are centered at 0. A standardized normal curve is centered at 0 with a standard deviation of 1. Okay, so that's why it is C. A standardized normal curve has a center of 0 and a standard deviation of 1. Okay, so again, your homework is the free response number 6 on pages 21 and 22. You need to go sit quietly for 15 to 20 minutes and time yourself on that free response question and see if you can get 2 points tomorrow when we grade it.